Alright, we got an ice machine here. It's doing a little funny thing. Originally said calling for making ice, but according to that, we're not getting the compressor to run. When you come up here, the compressor's not hot, so I don't know why it's not running. It's not even calling for it to run, but yet it thinks it should be running, but it's not running. Now, that was warm at one time. Yeah, there it is, dumping the water out. This is acting very odd. So right there, it just did the dump valve. It's acting very, very odd. So we installed the control board yesterday. Here's some of the history. Maximum freeze, nothing. That's a little weird. Let's go to that. This is not jiving. Something is very wrong. Okay, enable relays. And there it did it. So we got the contactor in. You can hear the compressor running. You can see the pump there running. That's hooked up. You can feel that solenoid. You can feel that solenoid. And the compressor is definitely running. So everything for the most part looks like it's probably working. Here's the water valve. Which should be able to look down below and see if that's working. Yeah. So the water valve's working. So all the relays are working. Let's do a self-check. See what we get there. Something seems a little peculiar here. But I don't know why I would say it was making ice and then... Okay. Keypad test, so when you do this it'll correspond. So see that one there, top one, bottom one, top left, top right, bottom right, and bottom left. And then you gotta do 5 to the right to get out of here. 5. Yes. So we've already done all that, so we can exit that. So that's interesting. So now let's go to make ice and see what it does. First thing it should do is pump it out and dump it and start to fill and start to freeze with the pump off. So let's see what happens here. So we got to make an ice, and she is running the compressor and the water valve is on. This is definitely a little bit odd. It's almost like it had a glitch. These plugs are in. I've already checked my T sensors here. Ground's hooked up. Curtain we know works. We can go in there and look at our microphone. So discharge gas is 130. Liquid, I believe, 114, which seems a little high. That's where it's at. This will tell you where things are at and what's going on. May have to go up on the roof, take a look up on the roof. Might have something going on with that. That's not going to help it none if it's too hot. See, now we're actually dropping in temp, and our delta T is 3. Usually want 7 or less. That makes me think that coil's a little bit dirty up on the roof, so I may have to go up there and take a look. So I scraped a little bit off there with my brush. You can see it's kind of packed, and the cottonwood's getting kind of bad. In this this location, someone else maintains it until it breaks, and then we get called. So I'm gonna go ahead and finish cleaning this off. Got me a new brush, fancy new brush, and it does a wonderful good job. So just wonderful. So yeah, we'll just get this thing cleaned up, and then we're gonna go down there and see how it does. But what's weird is this would not have caused that board to do that weird thing that it's doing. There's no reason for that to have given that, say that it's making ice and it's not, and not run the compressor. So I still think, you know, obviously this would cause some issues, but it would not cause the issue we got. Anyhow, we're gonna get this cleaned up. Okay, it looks like we dropped some ice because we're in a pre-chill already. Our liquid temperature there is at 97, which is a lot better than 113, which that may change a little bit as we start running. We're gonna check our pressures while we're at it, just because it felt a little bit cool up there for being a hot day. Alright, so there's our pressures. We're into the freeze. We'll go ahead and start our stopwatch. We're going to watch that for 5 minutes and see where we're at. Just kind of looking at it makes me wonder, with that head pressure control on there and everything else, how we're doing. But we're gonna, oh, you know what, let's put that on the right refrigerant. That helped. There we go. So 102, that's a little better. So, and we got 95 degree liquid, which right there, minus 101. I'm just gonna watch it and see what we get. Like I said, this is really acting odd. Now it's making ice. We supposedly it was doing fine yesterday after the board was replaced. So we have an IY069 6N261. So the I is that it is a indigo machine. The Y is the type of cube it is. It's a half dice. The 1000 is the machine series. They're testing the sirens for the emergency test they do. So 696 is what the machine is. The W is a self-contained water, which mine is an N for Nancy. So it's remote cooled, that's correct. So anyhow, we pop over here to the IO600 series. So we come down, we look at it. This is self-contained remote. So here's a remote. So on the air temperature, today's about 85 to 90, and our water's coming in probably in the 50 range. Harvest should be about 1.5 minutes to 2 minutes and a half, and the freeze cycle should be about 9 to 10.7 freeze time. So there's your production and operating pressures. Operating pressures look like it should be a little bit higher. I was wondering if it may be just a little bit low. So problem with these is you're supposed to pull all the refrigerant out and then weigh it in. We'll go back in there and see what we got. We'll see how long it takes to harvest and freeze. That's the biggest thing. Is usually if you can freeze, that's usually not such a big deal. Harvest is where you usually choke if you're low on refrigerant. All right, so we're about 8 minutes into it, and it's, like I said, about 85 out. So we're running at the very bottom, 245, and section's around that 41 range. So the 41 range technically works out okay there too. So we're just going to watch it and see how long it takes to freeze. Should be right around 10 minutes. Alright, so our delta T across that coil is starting to lose whack. So that kind of tells me that we might be, now there it's coming back. It's a very good chance it might be a little low. We may add a pound or two to it and get them going. Like I said, it's a weekend. We don't want to spend a bunch of time here. Also, superheat on this is running about 33 degrees. Basically, we're coming out. There's our sensing bulb. Here's our TXV. We're getting right there before we start to combine together with the liquid line. You want to do it there so you don't throw off your readings. So everything kind of just leads me that direction. It might just be a little bit low. I am not a fan of those quick connects at all. Alright, we're in harvest right now. About 1 minute and 20 in. And you look at your harvest pressures for around 80 degrees. It'll be 135 to 200 for your head. and 80, 75 to 100 for your suction. So I went ahead and added about 2.5 pounds to it. It holds about 7 pounds. There it comes. Gonna drop. That ain't good. Yeah, it's got some issues. But yeah, we added 2.5 pounds to it. And I'm gonna go with that for right now. We're gonna need to come back and probably do an extensive search on it, depending on whether he wants to or not. Just watch it again, see what we get. I'm gonna thicken that up a little bit too. I think it's not quite heavy enough to drop correctly, and I don't know when the last time this thing was cleaned. Cleaning's key to a nice slippery coil to watch your ice fall off. Alright, so we're running 100-degree liquid, extracting about 38 degrees of heat out of that, and our delta T between our in and outgoing evaporator plates 5. So we're running about a 27-degree superheat, which seems a little high, but it seems to be feeding pretty good and freezing fairly decent. So if it ain't broke, don't fix it. I mean, if it's not causing the malfunction, they're not going to want to change anything. Run her until the wheels fall off type thing. So basically, after adding that to it, we're going to retime it here and see what we got. She just went into harvest. That's after I adjusted it a little bit thicker. We're going to do a scan there with the Stratus, see if we can find a leak on those fittings or somewhere, wherever it's hiding at. See how long this thing takes to drop. A little more weight, fell a little bit better, right at a minute 21. Looks a little bit better. Alright, we went ahead and emptied the ice out of here so we can see exactly what we got. And basically, put it all back together, which this is how you really want to test it out. You want all that heat blocked out as much as possible. Technically, you want this door shut. Any of the heat from inside here can cause a lot of things to be off. So we went ahead and scanned it for leaks. I didn't find anything down here, which, you know, it very easily could be in the coil up on the roof. But we're going to leave it up to them whether they want to look any deeper for it. And like I said, this is not the right way of charging it. You're supposed to pull it out and weigh it in. But I also looked at the total charge, which is 7 pounds, and then I added a little bit to it. I kind of based it off of my superheat of my valve and my liquid line temperature and condensing temperature, along with the charts of suction and pressure without the ambient all combined together. So that's how we kind of came up with it. So not everything is done exactly by the book, especially on a Saturday when you're trying to get this done and get it out of here, get them up and going. Because as you can see, once that's gone, they wouldn't have ice for their drinks. So it sounds like it's getting ready to go into harvest now. Yeah, it is. So we're going to time this again. We're off by a little bit here, so we'll add about 15 seconds to it. These aren't quite the same as the old ones that used to have only 3.5 minutes. These have got a little bit longer leeway on it, and then the newest ones basically have an even different one than what the Indiglo here's got, as far as timing before it malfunctions and locks out. But like I said, nothing here explains why this was running without the compressor, and yet it wasn't locked out completely, but yet it was trying to run. So unless they got some sort of blimp, maybe something didn't save correctly, I don't know what, but we did make it better. It's running cooler. There she goes. Ridge thickness could go a little bit thicker yet, so it's supposed to be about 1/8 of an inch. So we'll adjust that real quick. Alright, so we adjusted that. You gotta be careful, you don't want to go too thick because that'll cause you issues too. This is not supposed to be in the ice, but that got knocked off when it dropped, so I don't know. This is not the original one that was in there. Alright guys, so basically what we had there was a dirty coil, and I believe what was going on is it was tripping the high pressure cutout and it was shutting the machine down. I haven't seen a machine do what it did as far as trying to run the water, but yet not run the compressor. That might have been the safe mode reaction. I'm not 100% certain. Basically, had a dirty coil. Recommend they clean it more often or have us clean it. I added a little bit to the refrigerant charge. I know this particular customer doesn't probably want to do any further work than what was already done. So basically, I added a little bit to it. Like I said in the video, that charge should be pulled and weighed in, but today's Saturday. We're not going to waste a lot of time going over and yanking it out, weighing it in. Sometimes you just got to do what you got to do to make things run the way it should, while balancing that with all the facts as far as your head pressure, your suction pressure, your subcooling, and your superheat on your valve. So the thickness helped out a lot. When I got done there, I ended up taking my knife and kind of smoothing any sharp edges at the bottom of the water curtain that might have been holding on to the ice when it didn't want to drop that one time. So any of those things there can all help get the ice out of the machine quick as possible. And thinner will make the machine cycle faster, but they won't last as long. So you got to do what the manufacturer recommends, which is try to get, this particular one wants a 1/8 of an inch gap between the cubes, which they call it the bridge thickness. So we took it to that, and it was a heavier ice, so it's going to last longer. It takes a little longer to make, but it also is heavier, so it drops out of the machine and drops down in there. So anyhow, if you guys like the video and you want to see more like it, give it a thumbs up. And until next time, guys, we'll catch you on the next one.